Now we know how to go up and down. We know how to go right and left. So now let's learn how to flip stuff. Okay. So we're gonna talk about reflections. This is gonna be flipping with respect to the x-axis, flipping with respect to the y-axis. Okay. How we turn pictures around. So that's the next transformation that we discussed. And just like the other two, let's start with a little example so we can see what's happening here. So let's see, who can tell me verbally what are the rules that we have introduced so far? What are the rules that we're allowed to do to the formula?
You can translate it like horizontally and shift it vertically.
Okay, so to the formula. So the algebraic rules, what are they?
Oh, add.
You can add and subtract what? Be more specific.
Like, numbers
To what?
to the x to the parent function.
So what does that do?
It can shift horizontally or vertically.
No, it's sent up and down. When you add to the function, you're adding to the whole formula, right? You're adding to the y. Remember, the function is y. So if you add or subtract a number to the entire function, to the parent function, as you said, that's a vertical shift, right? Up or down. That's one rule. What's the other rule that we can do?
You can add or subtract to the x.
To the x directly. So we can replace x by x plus something or x minus something. What transformation is that? As a horizontal shift. Okay? Remember, you say add and subtract, what do you mean? There are many things you can do with add and subtract. You can add and subtract to the whole thing or to something specific, like in this case is the x for the second rule. Okay? So we have those two rules. Now let's introduce another one. So let's talk about reflection. So for example, you can also multiply a function by something. In this case, we're going to multiply by a very specific number. In our case, it's -1. Question is, what happens when you take a function and you multiply it by -1? Okay, that's what we want to explore now. So again, example, let us graph the function y equals -square root of x. So you're allowed to multiply functions by a number. Right now, the only number that we are exploring is this one, multiplying by -1. Later, we're going to see what happens when you multiply by a number that's different than 1. Okay? If you multiply by a negative number like -3, we're going to consider that as two transformations. Okay? One transformation is a negative because -3 is -1 times 3. So one transformation will be the negative, and then the other transformation will be the times 3, which we will address later on. Okay, so how would this graph look like? What do you think? What do you think we should do here? What happens when you multiply stuff by negative? By -1? If you multiply a number by -1, what is it that you're doing? You're changing the sign. If it was positive, what happens? Becomes negative. And if it was negative, what happens? It becomes positive. Now here, what are we affecting? First of all, what's the parent function? The square root function. So let's write it down. So let's graph the square root function so we can see it. So it's a square root function, goes to 0, 0, 1, 1, then I guess, let's say 4,2. So that's a square root function, and then we want to sketch this other function. So what we're doing is we're multiplying this function by -1, yes? So what we're doing is we're affecting the y value, right? So what we're saying, because remember, the whole thing, we're affecting the y's of this function because the y of this is square root of x. Do you understand this? So we don't touch the x's, we touch the y, and all we are saying is whatever was positive now is going to be negative, and if something was negative, it's going to be positive. Okay? So in this particular case, there's nothing negative, so we don't have to worry about that. But all this stuff that is positive, remember, in terms of the graph, positive means above the x-axis. We talked about this last time. So if it's positive now, it has to be negative. Where does it go? Below the x-axis. So this picture is going to go down here. But you need to preserve distances. So for example, if this is a distance of 1 from the x-axis, then the same thing is going to happen, but down here, distance of 1. Okay? If this distance is 2, the same thing is going to happen, but down here, distance of 2. In other words, the x-axis will be like a mirror, and what you're doing is you're reflecting whatever is above the x-axis, you're reflecting it down to below the x-axis. Okay? So this is a reflection about the x-axis. And there is one point that is fixed. Any point that's on the x-axis stays there, right? Because a point on the x-axis is neither positive nor negative. The y is already 0, so that point stays there. So this point is not going to move. Then this one is going to go down here, and then 4,2 is going to go down here. Okay? And then we're going to have exactly the same shape. So we have this behavior. So there are two functions here, okay? The function on the top is the parent function, which is square root of x. The function in the bottom is the one that we are interested in, which is minus square root of x. Do you understand this? So, you know, if you wanted to graph this function by itself, the picture then would be something like this. Right? That's the graph. 0, 0. At this time, it goes through 1, -1, and so on. So that would be the graph of y equals negative square root of x. All right. Questions? And again, if we have something going on above and below the x-axis, then it will go up. Okay. So, for example, if you multiply the cubic function is like this. If you multiply by -1, what sort of picture do you get? So flip the picture. So you will get this. The red. You understand this? So this part comes here, and this one comes here. All right. Okay. So what happens here is a reflection about the x-axis. So let me say that. So what's happening here is a reflection about the x-axis. So that is what multiplying an entire function by -1 does. All right, so let's talk about that. So theorem. That's reflection about the x-axis, and then the statement is that y equals negative f of x. This is, you know, the formal transformation. You have your function, whatever it is, and we are multiplying it by -1. Okay. So when you stick a minus in front, when you do this, what you're doing is you're reflecting. So this is the reflection. Is a reflection of the graph of f of x about the x-axis. Do you understand this? So you flip the graph, okay? All right, so let's do an example. So example, let us sketch the following function. So sketch the function f of x equals negative absolute value of x minus 3 plus 2. All right. So again, now there will be multiple transformations combined. Okay. So let's set some ground rules. Okay. You should not move the picture. You should not do any horizontal or vertical shift until you are done with any reflections or stretches, if there are any. Okay. For example, here we see that there is a reflection going on because of the negative here. Okay. So you need to do this one before you start thinking about moving around. Okay. Because when you move away from the starting point of the graph, then it becomes less straightforward to figure out how the reflection goes. For example, it's pretty easy to flip the square root. You know, to do this is pretty easy when the square root is in its initial position. But imagine that you wanted to flip something like this. For example, let's say that you have this, and this is a 3. What would be the graph of this? What's the equation for this one?
Square root of x plus 3.
This would be square root of x plus 3, okay? But then let's say that you wanted to reflect this one. So let's say that I gave you this picture. Okay? let's say that I gave you this. I gave you this then to graph. You may think of it as being, for example, if you wanna, first of all, this is a little bit misleading, okay? Because if you try to do this first, to start with square root, then if you try to go down and then you try to flip, that's not gonna work. Because if you go down and then you flip, you're really graphing negative square root of x plus 3. So that's another complication. But let's say that here you recognize that this is like this. Factor out the negative. So then you say, okay, this is just this function reflect, right? How do you reflect this function about the x-axis? So it's not as simple as just doing this. Do you understand that? Probably means that you need to keep the same distance from the x-axis. Remember, the x-axis is the mirror. So if this point is a distance of 3, then this point has to go all the way down here to negative 3. Okay? We have to go all the way down here, and so on and so forth. So really, the reflection will be down here. Do you understand what I'm saying? Whatever gap you have in here, you have to keep it around the x-axis. This is a mirror, so this distance has to be the same as this. If there is a mirror on the wall, your image is supposed to be, if I'm standing here, my image is going to be far away in the same distance on the other side. If there are two words and the mirror is the door, then, it's not right there, it's a distance from the wall, the same distance as I am. That's what's happening here. So if you are away from the mirror, then, it's less straightforward to figure out the reflection. That's why, if there is a reflection, you should do it before you get to move. For example, an easy way to do this would have been, okay, I start with my square root, then I'm going to do minus square root of x, which is flip it, and then I do the minus 3. I take it down. And you're going to end up in the same place, but it's more intuitive than doing this, and then going up and doing this big reflection. It's easier to reflect first and then go down. Do you understand what I'm saying? So the rules that I'm telling you is, when there are multiple transformations involved, just do as much as you can in here before you start moving around yourself. And what I mean by that is, right now, the only thing that we can do that's not movement is reflection. But later, we're going to talk about stretching and compressing stuff. So you should do any reflection, stretch, or compression in here, and then you do any horizontal shift, and then lastly, you do any vertical shift. Yourself. Okay? So that's a sequence of steps that I recommend you to follow to make sure that you get to the right picture. Okay. Anyways, we're gonna see that in the examples. So, because there are several subtleties in this kind of problems. I always remember the rules. We have 3 rules now. You can add and subtract a number to the entire function. You can replace x by x plus something or x minus something. And now we are also allowed to multiply an entire function by -1. That's the only thing that we are allowed to do so far. Okay. So let's do this. What's the parent function?
Absolute value of x.
The absolute value function. So we begin with this. And now, how many transformations are we doing to this parent function? 3 transformations. What are they?
Reflection,
A reflection about the x-axis,
this would be right,
right,
and then going up to units.
and then up to units. Yes? Good. And then this, if you recognize that, then this will easily guide you what formulas you need to write. So remember, one thing that we can do is, we can go ahead and multiply this by -1. That's a rule that we're allowed to do. Nobody can stop you from doing that. You can multiply a function by -1. So we're slowly building our way towards the formula. We already have the minus that we wanted and the absolute value. Now, this is not what we want. We want x minus 3. Can we do that? Yes, we can. We are allowed to replace x by x minus 1. Okay? So that's the next thing that we do. We replace x by x minus 3, and we have to keep everything else as it was. So the minus that was already there stays there. We just, from here to here, what we did was we replaced x by x minus 3. So let's write what's happening. So here, what we're doing is reflect about x-axis Then from 2 to 3, what we're doing is we're going right 3 units. And then lastly, if we want to build our function, the only thing that we need is a +2 in here, and yes, we're allowed to add a number to our entire formula. So that's a value operation. So then step 4, we take whatever we had in step 3 and then we do +2. So we know that what's happening here is going up 2 units. Do you understand this? Okay, so let's do it. All right, so now we backtrack to the beginning, start with a basic function, and then start doing all of these things. So we start with absolute value. You know how it looks. That's x, y, and then we have a little V shape, 0, 0, 1, 1, negative 1, comma 1. Those are our key points that we're going to start moving around. Okay. All right. So next, we're going to reflect about the x-axis. So whatever is above goes below, and if there is something below, it will go above. But that's not the case here. So I guess I'm going to put my x-axis up here. So 0, 0 is going to stay there. Now 1, 1 is going to go down here to negative 1, and then negative 1, comma 1 goes down here, and we have our V shape going this way. Okay, so the picture got flipped. Next, we're going to take this picture and shift it to the right 3 units. So 0, 0 is going to go to 1, 2, 3, comma 0. Then 1, comma negative 1 is going to go to 4, comma negative 1. And then negative 1, comma negative 1 is going to go to, what is it? To 2, comma negative 1. And then we draw. So this time we get a y-intercept, and that happens at negative 3, right? When x is equal to 0, you get negative 3. So it's going to be right here. Let's force it. Here we go. So that's our function so far. And then lastly, from 3 to 4, what we're doing is we're taking this picture and we're pulling this up 2 units. Okay? Which is final outcome. X, Y. Well, let's see. The point 3, 0 is going to go up 2 units, so I will be now at 3, 2. So let's say this is 1, this is 2, this is 3, this one is 4, 1, 2. So the point is going to be up here. Then 4, negative 1 is going to be up to 4, 1. Then 2, negative 1 goes up to 2, 1. And then also the y-intercept is going to move up from negative 3 to negative 1. Okay. And then we sketch. Get something like this. Is this picture complete? We're missing something. What are we missing? What information are we missing from this picture? The x-intercept. So we need to find them. Okay. If this scale was nice, it appears that we're going to 1 here. And let's see if that's the case. Now, if this is 1, what are we expecting this guy to be? 5, because use symmetry. Remember, this is a symmetric picture. The original one was symmetric with respect to the y-axis. Now things are moving, but if you follow along the line of symmetry, which is this one, it's still the same one here. Now this time, from 2 to 3, the line of symmetry went from x equals 0 to x equals 3. Now this picture is symmetric with respect to the line x equals 3. Okay? Meaning if you follow along that line, then the two pieces will overlap. and therefore our picture went up, so still symmetric with respect to this line. So what that means is that whatever is happening to the left, the same thing must happen to the right, same distance. So if this point here is a distance of 2, then if you go a distance of 2, you need to find another point. Okay? So if the x-intercept happens to be 1 here, then you need to have 5 over here as well. But anyways, let's figure it out. We just solve the equation. The y-intercept is already there. There's no need to find it. But then for the x-intercept, we need to solve this little absolute value equation, right? So this means absolute value of x minus 3 equals positive 2. Because you move the negative 2, but then divide by negative 1. So there are two choices here. Either x minus 3 is 2 or negative 2. So indeed, we get that x is either 5 or 1. So now we can confidently say, remember, never let the picture tell you what's going on. You need to figure it out by solving the equation, because if you don't have a perfect scale, then this would have been misleading. Okay, so you have to be careful. But indeed, we do see the two intercepts in there. So now our picture is complete. Okay, it has everything that we need. All right, questions? So even though it looks a little bit long, I strongly encourage you to do these things one step at a time. When you start missing steps together, it's very easy to get the problem wrong, and to get the wrong picture, and to end up in the wrong place with the wrong points. Okay? So even though it will take a little bit longer, just take it slow, one at a time, and then you will be able to get to the final picture without issues. And hopefully you see now why it's important to know the basic function, because if you don't know that absolute value looks like this, there's no way you can do something like this. Okay? Because yes, you could do the entire plan with your formulas, but then when it comes to actually graph stuff, you're stuck right here in the first step. Okay? That's why it's important to recognize all those basic functions. Okay, questions about reflections about the x-axis? All right. So now there's another reflection. For example, this one. So how about graph the function f of x equals the square root of negative x. Why?
Because the negative reflects it across the line. I just know it is, I just don't know why.
Yes, but try to explain. Yes, it's a good thing to think about how would you explain an idea, because that really helps you really understand what happened, right?
If you think about square root, it has to be positive under the square root. And the only way you can have a positive with that negative there is by having negative x's.
Exactly. So normally our x is to the right, yes, because our x has to be positive. But the moment that we introduce this negative, what are we saying all of a sudden? Wait a minute, now those positive guys are not good anymore. If you want this to make sense, you better plug in negative stuff. So then this negative will make it positive. Do you understand this? So you are forced to look to the left. If you were looking to the right before, so let me draw a picture. So hopefully everybody understands that this comes from the square root, right? That's our parent function here. So let's have it here as a reference. So here is our parent function. But the thing about this function is that now, this function only admits positive inputs. But our function, if you plug in something like this, you're going to get a negative inside the square root. And as you know, we don't want that. So our function is forced to look this way, right? But still, if you want to end up doing square root, it's just that it's going to be pointing in this direction. For example, if you want to get to 0, then you still plug in 0. That's fine. But if you want to go up here with the square root, eventually you need to have a 1 in here. But to have a 1 in here this time, instead of plugging 1, you have to plug in negative 1. You understand this? So that means we are forced to go here to obtain 1. So this point is like sent this way. Okay? Similarly, let's say 2, So if you want to obtain 2 as an output here, that means we need to have a 4 inside the square root. But to be able to get a 4 here, this time you cannot plug in a 4 anymore. Instead, you have to plug in a -4 so that you can make it positive, right? So that means you're forced to go this way. Let's say over here, if you want to go up to 2. In other words, this point that was here, this point is sent over here, okay? And so on and so forth. Every single point in this picture is going to be sent to the other side, and as the classmate pointed out, that means that we're just reflecting about the y-axis. Same way that before we're reflecting about the x, this time we're reflecting about the y. So we're going to end up with this picture, okay? So this would be f of x. So if we do it along, so x and y, then the graph of y equals square root of negative x, the graph of that would be something like this, okay? Okay, questions? So you can multiply an entire function by -1. When you do that, what happens? If you multiply the entire formula by -1, as reflection about the x-axis. But now you are also allowed to replace x by -x. In other words, you multiply the x directly by -1, right? If you do that, what happens? Reflection about the y-axis, okay? So notice that, by the way, okay, I should have called this G, so I'm going to call it G right now. Let's call it G. And then the square root, let's call it F. So how can we write this in terms of F? Using F, how can we write that formula? F of negative x, very good. Okay, so remember, before was minus f of x, because you're multiplying the entire formula by a negative. This time you want to multiply the x directly by a negative, so you want to replace x by negative x. That's another valid rule, then this is how we write it, okay? F of negative x. This means replace x by negative x. Everybody okay with this? And what it does is, it reflects about the y-axis. So what we see here is a reflection about the y-axis. Are we good? All right, perfect. So I guess let me write it down. So theorem okay, so let me ask you a question. If you have an even function, what happens when we try to do this transformation? Function stays the same, right? If you have an odd function, what happens when we combine these two transformations? When you reflect about the x and then about the y, go back to original position. Because remember, even means f of negative x equals f of x, that's even. So that means if you want to reflect about the y, your picture stays the same. You have your parabola, you flip it, you still get the same parabola. Yes? Now, odd means that f of negative x is minus f of x. In other words, it doesn't matter. This is actually telling us that you can either reflect about the y or about the x, you're going to obtain the same picture. Okay? The same outcome. Now, if you do this transformation twice, which would mean this, right? Reflect about the y, then reflect about the x, or reflect about the x, then reflect about the y, however you want to call it. What do you end up with in here? What is this? Just with f of x. So, if you have an odd function, if you do these two transformations, you're going to end up in the place that you started with. Okay? So, I don't know, some fun little facts like that. Okay. So, let's write the statement. The theorem, this is reflection about the y-axis, and the function y equals f of negative x is the reflection of the graph of f about the y-axis. Okay? All right. So, as an example, let us sketch, and then let's see. This time, let's do something that's slightly more complicated. Let's do this, and then I'll let you try this one. So remember, as a general rule, when you start graphing, first take care of any reflections before you start moving around. Okay? All right, so let's see. Let's talk about number one. So number one is a function f of x equals square root of negative x plus 2 plus 1. So far, we have never questioned the way the functions have been written. Okay? We haven't had to do anything. We just look at it and then we know exactly what's happening. But let's see, can you tell me what transformations are happening here? Like how many? I mean, it's clear what the parent function is. Yes? What's the parent function? Square root. Now tell me what transformation, how many transformations are we doing to it? What are they?
Reflection across the y2 to the left and then one up.
Y2 to the left.
Because it's inside the square.
No. So remember, to be able to do horizontal, you need to affect the x directly. Is this affecting the x? Is this plus 2 affecting x?
Are you talking about number one?
It's not affecting x, it's affecting negative x. It's not the same thing. Don't do this because it's not the same thing. Okay? X is not the same thing as negative x. You need to have x plus 2. We don't have x plus 2. We have negative x plus 2. Do you understand what I'm saying? So here, we kind of have the feeling that, okay, there is a reflection happening, and we have a feeling that there should be some sort of horizontal shift. Now, the question really is, which one is it? It's not clear from this one. Because if you want to say left, you need to have x plus 2. We don't have x plus 2. If you want to say right, you need to have x minus 2. We don't have x minus 2. So what that means is that the form that it was given to us is not good. I mean, if you want to keep this function written this way, it's not clear what transformations happen. So the question is, can we change it a little bit to understand what transformation is happening? I'm going to give you a tip. Whenever something like this shows up, and you have a negative in front of the x, factor out that negative. Okay? Factor out the negative, and then you will be able to see what's going on. For example, here, instead of keeping it like this, what I'm going to do is I'm going to factor out the negative. So I'm going to take out a negative. So now the negative x plus 2 becomes negative, parenthesis, x minus 2. And then plus 1. Now we have something that we recognize. Now I have an x minus 2 in here. Do you see what I'm saying? This is something that we recognize. This is one of the rules that we can have. So now we can say, okay, what's happening here? We have a reflection. You can see as we do the step little by little. We're going to have a reflection about the y-axis. We're going to go right 2 units because we replace x by x minus 2. Then we're going to go up 1 unit. Do you understand what I'm saying? Yes?
So they're functions on the y-axis, right?
Yes, each with respect to the y-axis. But we're not going left, we're going right. Is that clear? Okay. So the point is, you have to be careful. Remember the rules. I mean, You know, it's like when you get something, this is instruction manual, you have to follow the instruction manual, otherwise your machine is gonna break if you get outside of the instructions. Well, it's the same thing here. We don't know what this is. We know what this is. We don't know this. Okay? So you have to make it look like something that you can understand. Because this, we don't have a rule for this. Negative x plus 2. I don't know what this is. Now we can turn it into something that we know. How? Take out the negative, and then the truth is revealed. It's not really plus, it's really a minus. It's really an x minus 2, it's just that it's hidden because of this negative. I don't know if you understand what I'm trying to tell you. Okay? Remember, nobody's going to tell you this. You have to identify this yourself. And you see the problem. Okay? Remember, what you can do is x plus something or x minus something. Just x. All right? So the moment that you recognize this, then the rest is automatic. So parent function is a square root function. Now remember, one rule one step at a time. So if there is any reflection, we should do it first, and indeed we see a reflection right here. So are we allowed to replace x by negative x? Yes, we are. That's one of the rules. So let's do it. I replace x by negative x. This is telling me, okay, reflect about what? About the y-axis. Okay? So remember, we're going to slowly build our way towards this formula right here. Okay? This is the one that I'm focusing on right now. So we want to build our way slowly towards here. So remember, you are allowed to replace x by x plus something or x minus something. So what do we need? We need to replace x by x minus 2. We can do that. So we can replace x by x minus 2. And this, of course, is the same thing as this piece, okay? It's just that we write it like that to make it clear what transformation is taking place. So what's happening from 2 to 3? What's happening? So we are going right 2 units. And then lastly, what do we need to do to this formula to obtain our formula? Let's do a plus 1. So we look at the formula from step 3, and then we do plus 1, okay? And you know, at this point you can safely say, okay, this is just what we had already, okay? But we are following this version because this is the one that really is telling us what's happening from 2 to 3, which was slightly hidden from us. All right, so now that the plan is there, then we execute it. So remember, from 3 to 4, what's happening is we're going up 1 unit. All right, so start with our square root function. So 0, 0, 1, 1, good enough. Then reflect about the y-axis. So, you know, when you do this, give yourself enough space. Please don't draw tiny little pictures. Okay, there's no need to do that kind of stuff. Just make an effort, draw big, so I can see what you're doing. Okay. Remember, when you write something, usually, why do you write something? Usually, it's for somebody else to see, for somebody else to read it. Usually, sometimes you have your own journal or whatever, and you write for yourself. But most of the time, if you write, it's for somebody else to see it. Then take that into consideration. Be kind to others. Okay. So, reflection on the y-axis. We get something like that. Right, and so on. Then we need to take this picture now and send it to the right 2 units. So we pull it like this to the right. So x and y, so 0, 0 is going to go to 1, 2. And then negative 1, 1 is going to go to 0, 1. So right, 1, 1. Okay? And then we draw. Let's see, what's the y-intercept here? A y-intercept just show up. Which one is this guy? What is y-intercept? How do you find y-intercept? You should be able to tell me this in a split of a second. How do you find y-intercept? X equals 0. Put x equals 0. What do you get? Square root of 2. Right? This requires no thinking. Just x 0, so you know your value. This guy right here is square root of 2. Do you understand this? All right. And then next, what are we doing? And we take this picture and then we shift it up 1 unit. Okay. So that's x, that's y, and let's see, 2,0. So it's gonna go up here, 2,1. Then 1,1 is gonna go up to 1,2. And then we already have a y-intercept, which is gonna go from square root of 2 to square root of 2 plus 1. So that's 3 point something, so that's somewhere in here. Okay? So that's a y-intercept, now we draw. Yes? What happened?
Isn't that 2 point something?
Yeah? No? Yes. 2 point something. So it's below 3. It's before 3. So, yeah. And it was gonna be very uncomfortable for me to draw it. Okay, yes, so it's like 2.41. I think square root of 2 is 1.41. So about 2.41. So that's square root of 2 plus 1. Good. And then we sketch. This time we don't need to worry about any x-intercept because there's no x-intercept, so we're good to go. All right, questions? By the way, when I was in high school, I'm from Cuba, and we didn't have, I had a calculator, but we were not used to use calculators back then, so we needed to do everything, by hand. And in physics, not so much in math, but in physics, square root of 2, square root of 3, and square root of 5, they show up a lot. So you need to know, square root of 2 is 1.41, square root of 3 is 1.73, square root of 5 is 2.24, approximation, okay? So we need to know this, and then so you can do your calculations, division, multiplication, whenever they show up. And then if you already know trigonometry or something like that, the math books, like in the old days, they will come with a bunch of pages in the back, which will be a table of values. All values for sine, cosine, sine and cosine, tangent is not needed. Also the logarithmic values and log base 10, ln and log base 10, they will all come in tables because there were no calculators readily available for people to use.
They left the country before that came up.
So, technically, you guys should not be using calculators because then you miss this mental agility. Like I see people, I don't know, 20 minus 8, and then you see that they're doing this, or wait, let me get my phone. There's no reason to do that kind of stuff. But anyways, that's just I read something interesting the other day. It says tough times create tough/strong men. When I say men, it's a colloquial term for men and women, okay? But then good times at the same time creates a weaker man, because you don't need to really improvise or sacrifice yourself too much to survive and to be able to do good. So if you just do whatever, then that's enough and you're happy. But then when a difficulty comes, you don't know what to do. You don't know how to deal with that. So I read this in the way like I don't know. It was like, I don't know if it was a millionaire or something. It was some time ago that I read. But the point is that 3 generations before, like his great-great-grandfather really was having a very tough time and so on, but then was able to do something to create a small fortune. Then his father took over and created a bigger fortune and so on, and now he's good. But then he's saying, but then my great grandkids, right? Like my grandkids or something like that, probably they are gonna be doing the same thing that my great-great-grandfather had to do, because there will be a point that they'll be so weak that they will have to start all over again because they could lose their fortune or whatever. I don't know. Not sure why I'm saying this. Why am I saying this? Oh, because of the calculator business. Okay, so don't rely too much on the technology and all the commodities that you have nowadays. For example, can you get around without GPS?
Depends on where.
Depends on where. You should be able to get anywhere. You should be able to go anywhere without GPS.
I mean, you go on like Orlando,
Yes. How? Talk to people.
I mean,
Many people nowadays don't know how to talk to people. They just don't want to ask a question. Why? People used to talk to each other back in the days. Like when I give you the break, what last time was an interesting thing. This half of the class, everybody was chatting and so on. This half of the class, everybody was like this. I mean, that's fine, but talk. It's good to talk. Anyways, now we're in class, okay? But it's good to talk. All right, so we are done with this. Any questions? No? All right, so let's see. Here we have number 2. What time is it? I want to finish. Okay, so I'm going to take attendance. Try to graph number 2. Okay? Let me write it here. So it's minus square root of negative x plus 2. So sketch this one. Okay, so do we have a picture for this? Let's see, what are the transformations? So what's the parent function? Square root of x. What transformations are happening to it?
2 up.
You like to go against everything I say. That's the last thing that you do. What did I recommend you to do first? If any reflection show up, do that. Otherwise, you're gonna be getting in trouble for no reason. So.
You reflect across the x and the y.
Okay. So when it comes to reflection, it doesn't really matter which one you do first. Okay. Well, x or y, it doesn't matter, but do one of them. Okay. So across the x, there will be this guy. Then across the y, that will be this guy. Yes. And then.
No, that's y.
Then what do we do?
You reflect across the y.
We already did. So across the x,
So
across the y,
then you shift 2 up.
and then we go up to you. I mean, this one is what it is. Here you go up because once you do all of this is your formula, and then we do plus 2. We can do plus 2. Remember, you're allowed to do plus 2 to an entire formula. Do you understand this? This will be your new f of x, all of this. And then we just do plus 2 and we shift it up to you. Yes?
What about these 2 reflections? Wouldn't that just cancel out? So
No, because this is not an odd function. For example, because you're doing 2 reflections, what it's doing is this. You have the square root over here, then you send it here, here. So it's going from here to here. This is what it ends up with.
the one in the square root is for the x and for the y.
Say that again?
The reflection in the square root is for the x and for the y.
This one is for the x, this one is for the y. It doesn't matter the order. I mean, go here and then here. Like here, what I did was I did first y and then x. In this picture that I did.
But wouldn't the first minus be for the y one?
Yes, and this is x. This is reflection with respect to x. This brings stuff down.
Yeah, the y.
X. Reflection about what are you reflecting? What's your mirror? The y or the x-axis? So what's a mirror? The mirror is this guy. All right, so you're setting this down. Okay. Remember, here we're saying reflection about something. All right, so then let's do it. First, we have our square root function. Then we're gonna do, let's say, this one. So what is this?
Reflection across the x.
So reflect about the x-axis. Then let's say we do this one. What is this?
Reflection plus y.
So then we reflect about the y-axis. And then finally, remember, you can take any formula you want and add or subtract a number to the entire thing. So in this case, to obtain what we want, we just need to do a plus 2. Okay? So that's good enough. So we can do that. And what's that? From 3 to 4, what's happening? Up 2 units. You okay? All right, so now we do it. So start with square root function, 0, 0, 1, 1. Now we're going to reflect about the x-axis, so I'm going to take this picture and shift it down, okay? So 0, 0 stays there, but then 1, 1 becomes 1, negative 1. And we get this sort of picture. Okay, something like that. Then what are we going to do? We're going to reflect about the y-axis, so now we turn this to the other side, okay? So the in-between steps is up to you which one you want to use, okay? So you could decide to reflect about the y first and then about the x. It doesn't matter. The point is that once you reach step 3, you're going to end up in this location. So when you reach step 3, you're going to have a picture like this, okay? Now, your step 2 could have been different. Because maybe you decide to reflect like this first and then down, okay? Doesn't matter. At the end, you will end up in step number 3. And now, the final thing is we take this picture and we move it up 2 units. So 0, 0 goes up to 2. Then negative 1 goes up to 2 units, so negative 1, 1. And then we have something like this. Now we do see that we're going to have an x-intercept, right? So it's our job, our duty to find it. So how do we find this guy? How do we find it?
Make y equal to 0.
We make y equals to 0. So to find the x-intercept, we have our little equation. We set it equal to 0 and we solve. So this means square root of negative x equals 2. Square both sides. So negative x equals to 4. So x is negative 4. So this guy here is a negative 4. Now the picture is complete. Okay, questions? Even if it doesn't look like a negative 4, just put negative 4 in there and then move on. Yes? Because we did a reflection. You see, here, first we went down because we reflected about the x-axis. Now from 2 to 3, we did a reflection about the y-axis. That's what happens when you replace x by negative x. This minus right here is the one that's sending this picture to the left. So whatever is over here, you have to reflect it to this side. So we end up pointing this way, and now we put it up 2 units. Questions? All right. So what are the rules that we have so far? We can add and subtract a number to an entire function that makes it go up and down. We can replace x by x plus something or x minus something. That makes it up. That makes it go left and right. Yes. We can multiply the entire function by negative 1. That flips it about the x-axis. We can replace x by negative x. That flips it about the y-axis. Those are the transformations that we have discussed so far. And then the last one is that we can multiply a function by a number. Okay, it doesn't have to be -1. It could be a -3 or a 5. Okay, so what happens when you multiply by a number? What's going to happen is that we're going to create a dilation or a contraction of the picture. So we either stretch or shrink the picture when you do that. Okay,